Hello everyone and welcome to On the Spot STEM. Today we'll be tackling number 10 from the Aime I of 2019. Now this problem gives us a polynomial in the form x minus z1 cubed times x minus z2 cubed all the way to x minus z673 cubed, and it can be expressed as a polynomial in this form. Now they want to find the value of the absolute value of this summation, which looks pretty complicated, so let's try and break this problem down. Now, just the fact that they give us the first, second, and third coefficient, this problem almost screams Vietas, which basically states that, the sum of the roots will be equal to negative whatever that is, and then the sum of the double roots will be equal to whatever this is, and that's essentially the way Vietas goes. So let's try and look at how we'll apply Vietas to this problem. Now let's look at what the 20 represents. The 20 would represent the sum of the roots of whatever this polynomial is. And we might be tempted to say, okay, that's z1 plus z2 all the way to z673. But there's actually a small catch. There are more roots than the ones we just wrote down, because as we can notice, each root is a triple root because it's cubed. So z1 is actually represented in this sum 3 times. z2 is represented in this sum 3 times. z673 is represented in this sum 3 times. So we figure out that this is essentially what the 20 represents. Now, let's figure out what the 19 represents. So, before we figure out what the 19 represents, it's helpful to use some substitution so we don't have to write out a lot of different values. So let's let the sum that we want to find equal to s. And let's look at how this helps us. So the 19 represents all the pairs of roots multiplied together and then added up together. So that would represent, z1 times z2, z1 times z3, all the way to something like z672 times z673. And this is actually the sum that we would want to find. This is s. But unfortunately, the roots are all cubed. So this would be the same if that cube did not exist. But since that cube does exist, we actually have a bit of a different sum. In fact, how many occurrences of z1, z2 will there be? Well, there's 3 z1s that can pair with 3 z2s, so it makes sense that there are 9 of this, which is actually, we can translate that to 9s. But there's a small catch. If this were the problem, then it would be simple. We could just divide by 9 and get an answer of 28. But it's not this simple because z1 can also be multiplied by itself. So we actually get something along the lines of 9s plus z1 squared plus z2 squared all the way to z673 squared. And this sum would obviously get repeated a certain number of times. And for those of you who are curious, we know that z1 squared will repeat the same number of times as z2 squared because of the symmetric nature of this polynomial. But how many times will this repeat? Well, so we know that since there are three roots of z1 essentially, and we need to choose 2 of them to be multiplied by each other, we get 3 choose 2, which is 3 ways of this product occurring essentially. And that is what's equal to 19. So now it's time to use some algebraic manipulation to essentially figure out what this sum is so we can solve for what s is. Well, this shouldn't be too bad. Maybe we can use the earlier information we had here. So in order to turn a z1 into a z1 squared, we obviously would want to square this product. So if we were to divide by 3 and square this product, we'd get 20 over 3 squared is going to be equal to z1 plus z2 all the way to z673 squared. Now I just want to save time, so let's just rewrite the sum that we want to find as m. Now we can actually rewrite this whole portion as m, which is the whole z1 plus squared plus z2 squared, etc., plus 2 times s. Because we know that in this product we're not only going to get the sum of the squares, but we're also going to get z1 z2 plus z2 z1 plus z1 z3 plus z3 z1. And since z1 z2 equals z2 z1, there are 2 occurrences of every product occurring. So we know that m plus 2s will be equal to 400 over 9. So getting m alone, we now see that m is going to be equal to 400 over 9 minus 2s. So what this means is we can finally combine our equation from over here with our equation over here to get one big massive equation, where we get that. So we get this equation at last, where 19 equals 9s plus 3 times 400 over 9 minus 2s. So let's solve for s now. We know that 3s gets left on the right-hand side, and if we subtract 403 on both sides, we get 57 over 3 minus 400 over 3. And this, when we divide by 3 on both sides and actually solve it out, we get an answer of negative 343 over 9. Now, it's worth remembering that the answer there asked for the absolute value of that summation product thing. So if we take the absolute value and add the numerator and denominator, we get 343 plus 9, which equals 352. And so our final answer is 352.